Okay, welcome back, guys. We're going to be solving another question from chapter 4 of Johnston textbook. And we have this slender rod AB with a weight of W, and we know it's attached to block A and B, which can move freely in the guides shown. The blocks are connected by an elastic cord that passes over a pulley at point C. At the A part of the question, we need to express the tension in the cord in terms of W and theta. And in the B part, we need to determine the value of theta for which the tension in the cord is equal to 3W. So as always, we're going to start with the free body diagram. So we have this slender rod AB here. We have the weight, and we know this is going to make an angle theta. And we need to consider the reaction at A and B. So let's consider the reaction at point A in this direction. We're just going to assume for now, see what happens. And you might ask, how do you know if the normal force that we have would be from this wall to the block A or this one? And the answer is we don't know for now. What we can do is just to consider one single force as a resultant of these two in this direction and see what we get. And we're going to do the same thing for B, and this would be our force. And we have the tensions in the cord. So we have 1T here that is connected to block A, and we have 1T here which is connected to block B, and we know that this is the correct direction for the T because the cord can only be in tension. And if the cord is in tension, that means if this is our cord, on two sides it will be in tension, which means the force on the blocks has to be in the opposite direction based on the Newton's law. So these are the correct direction for the T. And that's pretty much it. We can proceed with our equilibrium equations where we have sum of all forces equals 0, and we have the same for moment. Okay, now we can start with our fx and fy. If we do our sum of all forces in x direction, we'll find that we have A and we have one of the T equals 0. That means our A is equal to T. And if we do sum of all forces in y direction, we have B in a positive direction, we have T, and we have W. And this shows our B is W minus T. Now let's do the moment about point C. If we do the moment about point C, we can cancel out the moment of the two tensions since the line of action passes through point C, which means we don't have any moment. So we have the moment of B, which is a counterclockwise moment, B times, and what we have from C to where the B is applying, and for that we know the length of the bar is L, so L cosine of theta would give us the distance. We also have the moment of W. This time that moment is a clockwise moment, so negative, and the distance will be simply what we have for L cosine of theta divided by 2. And the last one is the moment of A, which is again counterclockwise moment, so we have a positive moment A times this time L sine of theta. So we're just gonna put instead of B and L what we have found in the previous part. So B we have W minus T times L cosine of theta. The second is already based on W, and the last moment where we had A, we know A is equal to T, so we have TL sine of theta. So dividing each side by L, we can get rid of L, so we can, if we divide each side by L, same in here, we can get rid of the L's. So we have W cosine of theta minus T cosine of theta minus W divided by 2 cosine of theta plus the sine of theta equals 0. And let's see what we can do in here. So we have W cosine of theta minus half of W by cosine of theta, which means W divided by 2 cosine of theta minus T cosine of theta plus T sine of theta equals 0. And in here we can factor T. And if we do that, we'll have W divided by 2 cosine of theta minus t. And if that's the case, we'll get cosine of theta minus sine of theta equals 0. If we take this one to the other side, we'll have t equals to W cosine of theta divided by 2, and we'll have cosine of theta minus sine of theta. And that's the first part of the question, or A part, where we need to express the tension in the core in terms of W and theta. So we have W in here and everything's based on theta. And in the B part of the question, we just need to consider T equals to 3 times the weight. We'll have, and we're using what we found in here, is equal to W times cosine of theta divided by 2 cosine of theta minus sine of theta. And from here we can cancel out W on each side, and what we'll end up having is 6 times cosine of theta minus sine of theta is equal to cosine of theta. So in this side we can divide everything by cosine of theta, so we'll have 6 times cosine of theta divided by cosine of theta is 1 minus sine of theta over cosine of theta, which is tangent of theta, equal 1. That means 1 minus tangent of theta is 1 over 6, and tangent of theta will be 1 minus 1/6, which is 5/6. So if you want to find the theta, we simply have the tangent inverse of 5 over 6, and that would be 39.8 degrees. And that would be the B part of the answer, where we need to find the value of theta. And that would be all for this question. Please make sure to subscribe to the channel and let me know if you have any specific problem in your mind, then we can cover it in the next videos. You guys take care, and I'll see you in the next one.